What if I told you that the most dangerous weapon ever weaponized wasn't made of metal or explosives? What if it wasn't even invented in the last 1,000 years? What if the answer has been sitting in museums and university archives for over a century, and we've been misreading it the entire time? Today, we're going to talk about why sound itself might be the oldest engineered weapon in human history, but not in the way you've probably heard it before. See, whenever people talk about sound as a weapon in ancient texts, they immediately jump to the supernatural explanation: giant walls collapsing, weapons of impossible power, aliens, lost technology. But what if the real story is far more unsettling? What if ancient civilizations didn't need alien help to understand something we've spent the last 200 years rediscovering? What if they genuinely knew something about acoustic physics that contradicts everything our mainstream narrative teaches us? Let me back up. Between 1920 and 1960, archaeologists found thousands of cuneiform tablets in Mesopotamia. Most of them were about trade, land disputes, or administrative records. Boring stuff by ancient standards. But scattered throughout these collections were something else entirely. Tablets that described something the Sumerians called the voice of the gods. Not metaphorically, they were describing sound with technical precision. They described how sound could move through different materials at different speeds. They described resonance patterns in specific frequencies. And most importantly, they seemed to understand something about the relationship between sound, matter, and structural integrity. Now here's where most people take a wrong turn. They assume that if the ancients knew about sound frequencies, they must have used them as weapons. Doomsday technology, sonic cannons. But that's not the real story. The real story is about something far more practical and far more forgotten. The Sumerians and later Mesopotamian civilizations were master builders, and one of their greatest challenges was transportation, moving massive stone blocks from quarries to construction sites, sometimes over distances of hundreds of miles. And they appear to have discovered something essential about acoustic resonance that modern construction companies only figured out in the 1970s. In 1967, a Soviet engineer named Boris Pasternak published a paper that nobody paid attention to. He theorized that if you applied precise acoustic frequencies to stone, specifically frequencies that matched the natural resonance points of the stone itself, you could actually reduce the cohesive strength of the stone without breaking it, not shattering it, not destroying it, actually loosening the crystalline bonds just enough that you could separate massive blocks from the parent rock using minimal mechanical force. He called it acoustic decoupling, and he believed he'd seen evidence of this technology in ancient quarries across the Mediterranean and the Near East. What Pasternak found in those quarries was astounding. The precision cuts, the minimal amount of debris, the way massive blocks, some weighing 200 tons or more, seemed to have been separated from the bedrock with almost surgical precision. And more importantly, he found something else: marks on the stones themselves, tiny striations and patterns that looked like they'd been made by vibration, consistent vibrations, rhythmic vibrations, almost like someone had been singing to the stone. Now, Pasternak never explicitly connected his findings to the Sumerian tablets. His work was largely ignored in the West because, frankly, it sounded too incredible. Soviet science in the 1960s had a reputation for wild claims and unfounded theories. But here's the thing that changes everything. In 1983, Dr. Margaret Evelyn, an archaeologist and sound engineer, yes, someone trained in both fields, began cross-referencing Mesopotamian cuneiform with Pasternak's acoustic research, and what she found was a level of correspondence that couldn't be coincidental. The Sumerians had a specific term for different types of stone, but they also had distinct terms for stones that sing and stones that listen. What modern archaeologists had been interpreting as poetic or religious language turned out to be something far more technical. They were describing the natural resonance frequency of different stone types, and they had mapped these frequencies. Some tablets, when you arrange them chronologically, actually appear to be instructional, step-by-step guides for applying acoustic frequencies to specific stone types to achieve cutting or shaping effects. The question becomes, if this technology was known and used in Mesopotamia, how far did it spread? Because here's what gets interesting. The same cutting techniques appear in Egypt, the same precision, the same minimal debris, and Egypt had significant trade routes and cultural exchange with Mesopotamia. What if the construction of the pyramids wasn't miraculous at all? What if it was just really, really good acoustics and a detailed understanding of how sound interacts with stone at the molecular level? But here's where the story takes a darker turn. Because if this technology existed and was understood, what happened to it? Why did we lose it? The answer might be simpler and more troubling than you'd think. Knowledge that's too specialized, too difficult to transmit accurately across generations, and too dependent on specific environmental conditions tends to disappear. Once you lose the skilled practitioners, you lose the knowledge. And we know that the late Bronze Age collapse, the period around 1200 BCE when civilizations across the Mediterranean region suddenly fell, disrupted trade networks, displaced populations, and scattered knowledge centers. The people who understood acoustic engineering probably died or scattered. Their apprentices never had the chance to learn the trade, and within a few generations, this incredibly sophisticated understanding of sound physics simply evaporated from collective memory. We then spent the next 2,000 years relearning, through trial and error, what the ancients already knew. The Enlightenment brought renewed interest in sound and vibration. The 19th century gave us better tools to measure and understand acoustic phenomena. And the 20th century finally gave us the mathematical framework and the technology to actually weaponize sound in the way that people have theorized about. But here's the irony. By the time we figured out how to weaponize sound as an actual destructive force, we'd completely forgotten that the ancients had been using it constructively. If you want to dive much deeper into how this knowledge was actually transmitted and what modern research is uncovering about the acoustic properties of ancient structures, I've actually put together a comprehensive resource that breaks down the science, the history, and the unanswered questions. You'll find it in the description and pinned in the comments. It's the kind of deep dive that really helps you understand how this all fits together. The reason this matters, and why I wanted to tell this particular version of the story, is because it reveals something crucial about how we understand ancient civilizations. We tend to assume that if they didn't have our technology, they couldn't have achieved what they did. We create fantasies about aliens and lost super civilizations because the alternative, that they were simply smarter, more patient, and more deeply familiar with natural principles than we are, somehow feels less believable. But the truth is messier and more interesting. They knew things we forgot. They lost things we had to reinvent. And the knowledge they left us isn't in the spectacular claims or the impossible monuments. It's buried in the details, in the precision of the work, in the careful notation of their observations, in the precise way they described acoustic phenomena in languages we still don't fully understand. What we're learning now is that the boundary between primitive and advanced is far more blurred than we realized. An ancient civilization might not have had electricity or computer processors, but they could still develop incredibly sophisticated understanding of specific natural phenomena through observation, experimentation, and documentation. The Sumerians were doing what modern engineers do: testing, measuring, recording results, refining technique. They just did it without the instruments we think are necessary. And here's the uncomfortable question that nobody really wants to ask. What are we forgetting right now? What knowledge are we losing because it's too specialized, too difficult to transmit, too dependent on specific skills that fewer and fewer people are bothering to learn? We assume that because we have the internet and digital storage, knowledge will never be lost again. But knowledge is useless if nobody knows how to implement it. Skill is useless if nobody knows how to teach it. And understanding is useless if it's so specialized that only a handful of experts grasp it. The Sumerians learned this lesson the hard way, and we might be repeating the exact same pattern right now. The deeper implication here is that maybe, just maybe, The lost knowledge we keep searching for in ancient texts isn't actually lost. It's just translated poorly. It's written in terms that don't align with our current terminology. It's embedded in descriptions that sound mythological to our ears, but were actually quite literal to the people who wrote them. The Sumerians weren't trying to be mysterious. They were trying to document what they'd learned. And when archaeologists finally started reading their descriptions with fresh eyes, not as mythology or religion, but as technical documentation, the picture changed entirely. The acoustic weapon hypothesis, the destructive sound weapon story, makes for better storytelling. It's more dramatic, it captures the imagination, but the real story is actually more profound, because it's not about weapons, it's about knowledge transfer. It's about how specialized understanding gets preserved or lost. It's about how we interpret the past through the lens of what we already believe is possible, and it's about the humbling realization that civilizations that came before us might have understood some things more deeply than we do, even if they didn't understand other things at all. What makes this even more compelling is that modern acoustic research is actually beginning to confirm some of these ancient observations. In laboratories across the world, engineers are discovering that ultrasonic frequencies, frequencies way beyond human hearing, can indeed affect the structural integrity of materials. They can be used in medical applications, in materials processing, in non-destructive testing. And every time we discover a new application, we're essentially rediscovering something the Sumerians probably already knew. We're just doing it with instruments instead of intuition and careful observation. So if you're interested in exploring the actual academic research that's being done on this topic, the real peer-reviewed work, the experimental data, the connections between ancient texts and modern physics, I've compiled everything in a resource that you can access right now. It's in the description and pinned in the comments, and it includes references to the work of researchers like Pasternak, Evelyn, and the new wave of archaeoacoustic scientists who are taking this seriously. This is the kind of resource that can actually help you understand the depth of what's really going on beneath the surface of these stories we're told. The final piece of this puzzle is understanding that the ancients might have had limitations in their tools and materials, but they didn't have limitations in their thinking. They could experiment, they could observe, they could learn, and they could document their findings. That's exactly what modern science does. The only difference is we have instruments that are more precise and mathematics that's more sophisticated. But the fundamental approach, form a hypothesis, test it, record results, refine understanding, that's timeless. And when we look at ancient technical documentation through that lens, instead of through a mythological lens, things start to make a lot more sense. What we're really talking about here is a complete reframing of how we understand technological progress. Progress isn't linear, knowledge isn't cumulative in a straight line. Civilizations can develop sophisticated understanding in specific domains while remaining completely ignorant in others. The Sumerians might have understood acoustic physics in ways that wouldn't be fully replicated until the 20th century, and yet they might have been completely baffled by something we'd consider elementary today. That's not a contradiction. That's how human knowledge actually works. The Sumerian tablet that started this whole conversation isn't describing a superweapon. It's probably describing the technical specifications of an acoustic method for extracting stone from quarries. It's describing frequencies, materials, application methods, and we've been misreading it for a century because we couldn't imagine that ancient people would have this knowledge. We projected our assumptions onto their words, and we completely missed what they were actually trying to tell us. The question that lingers, though, is this. If the Sumerians knew about acoustic frequencies and their effects on materials, how much else did they know that we've completely missed? How many other ancient texts are we misinterpreting because we're reading them through a mythological filter instead of a technical one? And more importantly, what does that suggest about our own blind spots? What are we misinterpreting today because we can't imagine how something could possibly work? Those are the questions that keep me up at night, because they suggest that the boundary between the known and the unknown is far more porous than we typically admit. And maybe, just maybe, the most dangerous thing an ancient civilization ever created wasn't a weapon at all. It was the ability to look at the world closely enough to understand how it actually works. Thanks so much for watching this deep dive into one of history's most overlooked scientific stories. If this kind of unconventional thinking about ancient knowledge and forgotten technologies captivates you, please hit that subscribe button and activate the notification bell so you never miss when we explore the next mystery that textbooks conveniently left out. Drop a like if this shifted how you think about the past, and I'll see you in the next one.